This is the maximum absolute sum of any subarray problem. We're going to try and solve this with minimum complexities of O(n) time and O(1) space. The maximum absolute sum of any subarray problem asks us to find the maximum absolute sum that can be obtained from any subarray within an array of integers. So let's take a look at that problem statement here. We need to return the maximum absolute sum within these conditions. Your four options for an optimal solution here are A. Divide and conquer, B. Dynamic programming, C. Sort and sum, or D. Kadane's algorithm. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who were able to get it, congratulations. And for those of you who just need to see the code, the answer here is D, Kadane's algorithm. Let's take a look at our brute force approach, and in our application we get that from this hint button. We can consider all possible subarrays and calculate their sums. We'd iterate through all possible starting and ending points of these subarrays, calculate the sum for each, and keep track of the maximum absolute sum encountered. Obviously, our time complexity isn't ideal, and we'll avoid talking about the brute force approach any further. Let's take a look at our optimized solution using Kadane's algorithm. This utilizes the idea that the maximum subarray sum can be either the sum of a subarray or the sum of a prefix subarray and the sum of a suffix subarray. By keeping track of the maximum subarray sum ending at each index and the minimum subarray sum ending at each index, we can determine the maximum absolute sum using these abs values. So, we've got three functions at play here, and we're eventually returning the max of the max subarray, absolute value, and the minimum subarray using the absolute value. So we're using C++ here, and I'm going to go through this code line by line so that there's a clearer explanation. So our entry point to our solution is this function, and it looks quite simple. We're returning the maximum value between the absolute value of the maximum subarray sum, as given by maxarray nums, and the absolute value of the minimum subarray sum, as given by minarray nums, which is here. We're using the abs function in C++ to ensure that our returned value is positive and the maximum possible. And that will indeed be the maximum absolute sum. However, it's probably best if I go through how these two functions are using Kadane's algorithm, starting with the maxarray up at the top. So we're using the variable sz, and that's the size of our input vector nums, which represents the number of elements in the array. Maxsum until here initializes the variable with 0. This will store the maximum subarray sum ending at the current index. Result is initialized to int min in C++, initializing our result variable with the minimum possible integer value. This will keep track of the maximum subarray sum found so far. After that, we're starting a loop which iterates through each index of our vector. And then comes the key line at line 8. This line is calculating the maximum subarray sum ending at the current index. It takes the maximum value between 0, which starts a new subarray, and the sum of the maximum subarray ending at the previous index, as given by maxsum until here plus nums index. This comparison ensures that if the sum of the previous subarray is negative, we start a new subarray from the current element. After that, we have the result variable, which is updated with the maximum subarray sum found so far, as given by the maximum value between the current result and whatever max sum until here is. So that's line number 9. Finally, we return result, which should represent the maximum subarray sum. After that, let's look at min array, which is almost the same. We have our sz variable, which is the size of the nums array, and then min sum until here equals 0. This is initialized with 0 and will store the minimum subarray sum ending at the current index. Note that result is initialized to int max in this case, and result will be used to keep track of the minimum subarray sum found so far. We then have our for loop, which iterates through each index of our input vector, nums, and our two key lines are very similar again. First of all, this at line 19 is calculating the minimum subarray sum ending at the current index. It takes the minimum value between 0 to start the new subarray and the sum of the minimum subarray ending at the previous index, that is, min sum until here plus nums index. This comparison ensures that if the sum of the previous subarray is positive, we start a new subarray from the current element. We also use this line to update the result variable with the minimum subarray sum found so far. It takes the minimum value between the current result and min sum until here. Finally, we're returning result. So that's how the max absolute sum function is working, returning the maximum between the two absolute values returned from max array and min array. Hopefully that's helped you, and that's one more problem solving session completed with Coding Card Sharp. To check your understanding, I'm just going to ask the question one more time. And if you've been paying any attention, you'll know the answer is Curdain's algorithm. There's a brief explanation as to why. And our application also provides solutions in Python and Java as well. In any case, I hope that that's helped you. And if you need further help understanding this concept, I'll point you in the direction of this Udemy course, which is in the description to the video. Dr. Ibrahim offers a better technical explanation than I can give you, and usually offers a more visual example of the solution as well. Thank you very much for watching.